been on this notes packet forever. That's okay. We've been talking about other types of equations. And by other types of equations, I mean equations that have different things in them, like absolute value signs, root signs, third roots, square roots. And then we kind of moved on to talking about not just equations, but these things called inequalities, right? And inequalities are things that don't have an equal sign, but they either have one of these 5 signs at the tops, right? Usually less than, greater than, something like that. Now, we talked about how to graph inequalities and also write them in this thing called set builder notation, which WebAssign uses. And let's just review a little bit about these. When do I put a closed circle in my graph?
When it's equal to.
Good, less than or equal to or greater than or equal to, right? Open circle, let me show you here. An open circle here is because there's no line underneath the greater than, okay? Okay, going to the alternate notation, we always write where the arrow goes. So whatever 2 numbers the arrow is between, okay? With infinity, negative infinity or positive infinity, do I use a bracket or a parentheses? Parentheses. Parentheses are always used for infinities. Okay. Oh, sorry. And does a bracket mean we include the number or not include the number? Not include. Oh, wait. A bracket?
Oh.
Okay, yeah. A bracket means include, right? I know I've been saying a lot of words here. But bracket means that we include the number, kind of like a filled in circle. And parentheses means that we don't include the number, like an open circle. Okay. So I think we're pretty good with that. We talked about how to solve inequalities, and there was one thing that was really special about solving inequalities, and that is if we divide or multiply by a negative number, we have to flip the sign, right? So that's the only difference between inequalities and equations. Okay, why don't we go through this smaller example number 9 together, just to get back in the groove of this. Okay, so we have 4x minus 3 equals, or gosh, is less than 2x plus 5. Anything you guys want to do first? Steven? Yeah, so add the 3 to 5, good. Good, so we're gonna take 3 and add it to both sides of the equation, okay? Just like we do with an equation. 4x is less than 2x plus 8. Okay, maybe we want to move that 2x over, right? So let's subtract 2x from both sides. So that becomes 2x is less than 8. Okay. Good. Oh yeah, sorry. Divide 2 on both sides. Good. All right, x is less than 4. Huh?
You have to change the sign. So x is greater than 4.
Do I have to change the sign? But when do we change the sign for inequalities? Multiplying and dividing by a negative number, right? Did I multiply? I know I stuck this in to trick you guys. I divided by a positive number, I don't have to flip the sign. Okay, so this is a positive number, meaning the sign stays the same. The reason I flipped the sign on example 8 was because the sign was negative.
Right.
Yeah, I put that on purpose. Okay, so we have x is less than 4. We can always graph our answer, right? So if I had a number line, okay, 0. Oh gosh, I put that 0 way too close in the middle, didn't I? 0, 1, 2, 3, 4, 5. Okay. Since x is less than 4, I might want to put a circle above 4. Should I fill in the circle or not fill it in?
No.
No, right, because we're not including 4. And if x is less than 4, should I fill in to the left or to the right?
Left.
The left, right? And the thing is, I'm not very good at figuring out if I should fill it in to the left or to the right. I know that might be intuitive to you guys, but if you're ever confused as to where the arrow should go, you can always plug in a point and see if the inequality works, okay? So we could try x equals, give me an x value less than 4. 1, good. I can take my original inequality, 4x minus 3 less than 2x plus 5. I can plug in 1, 4 times 1 minus 3 less than 2 times 1 plus 5. Okay, 4 minus 3 is 1. 2 times 1 is 1 plus 5 is 7. 1 is less than 7, so that's why there's an error there. Okay, now I'm not going to do it, but if I pick like x equals 5 here, I would get something that wouldn't work. Okay, so that's why there's no error there. All right. Any questions on example 9? All right. Let's make things a little bit harder. Okay. Now we have an example of an equation where we have 2 inequalities. Okay. And I know it looks a little bit scary, but essentially what this question is it's asking us to solve 2 different inequalities and kind of piece the results together. Okay. So let me split this up into 2 different sides. I'm going to take this inequality and write it out. Negative 10 is less than negative 2x minus 6. Maybe I'm not going to write the right-hand side. And I'm going to split this inequality into negative 2x minus 6 is less than 12. Now that we have 2 separate inequalities, we can solve both of them, right? Okay, so looking at the left-hand side, I guess I need to add 6 to both sides, right? So we get negative 4 is less than or equal to 2x, negative 2x. Okay, guess I need to divide by negative 2, right? And on the left-hand side, I'm going to get 2. Am I flipping my sign or not?
You are.
Yes, we're flipping our sign because we're dividing by a negative number, and we're left with x on the right. Okay. Going to the right-hand side, I guess we need to add 6 on both sides. We get negative 2x is less than 18. And dividing by negative 2, we get x is something greater than negative 9. Good, because when we divide by a negative, we flip the sign. Okay, here's where things get a little bit tricky. I know for some people this is intuitive when we graph our results. To me, when I see x on the right-hand side of the inequality, it just messes me up and I don't know where to draw the lines on my graph. Okay, so let me show you what I do when I figure out how to draw this. I have 2 and negative 9. I'm just going to plot them on my graph, okay, because I know those are really important points. Okay, so I have 2 and I have negative 9. Okay, which one am I filling in? 2, good. Okay, now if you can read these signs and figure out where the arrow goes, that is perfect with me. What I like to do is kind of split this into 3 sections and check to see if each section gets an arrow or not. Okay, so what I mean by that is let me take a number less than 9. Or sorry, less than negative 9. Can someone give me a number less than negative 9? That's greater than negative 9.
Oh, it's 10.
Negative 10 is good. All right. I know I'm pretty bad at that too. If you don't believe me, then just take a look at my arithmetic skills. Okay. I've picked a number less than negative 9. Going to my original equation, I'm going to write out this entire inequality. So we have 10 is less than or equal to negative 2x minus 6 less than 12. Okay, just like we did when we had one inequality, let's plug in negative 10 and see if it works. So we have 10 is less than or equal to negative 2 times negative 10 is 20, minus 6 is less than 12. Okay, 20 minus 6 is 14, right? Okay, so negative, oh gosh, 10 is less than or equal to 14 is less than 12. Is that something that works? No, right, because 14 isn't less than 12. So I'm gonna put a big X here. And that means there's no arrow going to the left, okay? All right. Give me a number between -9 and 2. That's kind of hard. See, 0 is easy. I like -5 would work. I'm gonna choose 0 because 0 is easier for me to plug in. Okay. So -10 is less than or equal to -2x minus 6 less than 12. Plugging in, we get -2 times 0 is 0, minus 6 is less than 12. 10 is less than, -6 is less than 12. Does that work? Oh my gosh, wait. Oh, it's negative. Oh, I didn't put that in my last one either, didn't I? Thanks. I was like, this is supposed to work. Okay, does it work now? Yes, okay. So if it works, I can put an arrow in that area. Okay, so I can connect those two dots. Okay. Next thing we'll check. What's a number bigger than 2? 4, we can do 4. Okay. -10 less than or equal to, I'm not going to rewrite the equation again. -2 times 4 is -8 minus 6 is less than 12. Oh my goodness. What's -8 minus 6? -14, thanks. Okay, does that work? No, right? So there's no arrow to the right. Okay. So this is my fully graphed answer. I know I did a lot to do this. I know some of you can do this in your head. That's fine. This is how I like to do it so I don't make mistakes. Okay. If I were to type in my answer into WebAssign, I would need 2 numbers, right? So -9 and 2 seem like where the arrow is between. Which number gets the parentheses? -9, and 2 is filled in, so that gets the bracket. Yeah, so good. So if there's an open circle or we're not including -9, that's a parentheses. If we close the circle, we get a bracket. All right, so this is what I type into WebAssign. Let me just tell you one more thing about these types of questions. When we have the double inequality, usually the answer, so this is just for peace of mind when you're doing these questions, usually the answer either looks like this or it looks like this, okay? So if you're getting something where you have a middle and an arrow to the right, you might want to recheck to see if your numbers work out. Okay. Now, in this packet, I kind of made a mistake of making all the questions about the same. I didn't mean to do that, but we'll keep doing it. Okay. Any questions on example 10? Okay. If you flip to example number 11, you have a very similar question. Try this one out. Try to graph it. We'll come back in a little bit. Come back up to the front here. Let's go over this question. Nice job as I've been walking around. But let's just make sure we're all on the same page here. Okay, so I got Ainsley to write up the left-hand side and the right-hand side of this problem. Ainsley, do you want to go over the left-hand side? Mhm. Nice job. And the right-hand side kind of goes along the same page here. One thing, I got a good question as I've been walking around. I think Stephen asked, okay, this is a -2 here, and I'm dividing by something. Do I flip the sign? Okay, the answer is no, because what we're focusing on is the sign of the thing we're dividing by, okay, not by the thing we're dividing of. Yeah, let's talk about that. So we have -1 and 3, right? I got Riley to write up, okay, she knew that she had to put circles around -1 and 3, right? Now, when we have an open circle, it represents things that look like this. So let me actually write this out here. An open circle represents less than or greater than, okay? A closed circle represents less than or equal to or greater than or equal to. Okay, so depending on what the sign is, we close the circle if it's equal to, we open the circle if it's just less than or greater. All right, nice question there. All right, so Riley, do you want to kind of take us through how you got like the arrows and how you got your set builder notation?
So I picked a number that was less than -1. So I did -6 was less than 2 parentheses -2. That's less than -1. -4 is less than or equal to 2. You were to get -6 less than -4 minus 4 less than or equal to 2. And then -4 minus 4 equals -8. So you have -6 less than -8 less than or equal to -2. That's not right because -8 is greater than -6.
Perfect. Yep.
Pick the number between -1 and 3, and I pick 0. So -6 less than 2 times 0 minus 4 less than or equal to, or yeah, less than or equal to 2. Multiply that, you'll get 6 is less than -6 less than -4 less than or equal to 2, and that is right. And then to confirm that it closes at 3, I plugged in a number greater than 3. I picked 4. So it is -6 less than 2 times 4 minus 4 less than or equal to 2. 2 times 4 gives you 8. So I have -6 less than 8 minus 4 less than or equal to 2. 8 minus 4 equals 4. I have -6 less than -4 less than 4 less than or equal to 2. And that's not right because 4 is greater than 2.
Perfect job. I made you explain a lot here, but thanks for doing that. Then with our set builder notation, we have the two numbers. Riley made this one a parentheses because we have an open circle. 3 has a bracket because we have a closed circle. Any questions on this example here? All right. Let's do another one. Okay, we're actually moving to a different section now. Okay. Yeah, so we're dealing with inequalities still, but sometimes, okay, before I've been giving you some easy examples with inequalities, I've been giving you like linear examples. We can have inequalities with quadratics too. What does quadratic mean? Highest power is 2, right? So we have x squared going on. And remember, we have all these different techniques to be able to solve quadratics. Those still apply when we deal with inequalities. All right, so now we have to think back to before the test here. Okay, but now we just have one inequality, so going back to a little bit simpler, simpler world, right? Okay, so we have 2x squared minus x is less than 3. Okay, why don't we just pretend that we have an equal sign? Okay, let's just write the equation with an equal sign. Okay. Once we get the answer, we can graph our answer and then figure out where the arrows go. Okay. So taking a look at this one, what sort of method do you want to use for this? We have a couple methods to solve quadratics. Factoring sounds good, right? The numbers seem pretty easy to manipulate, so we can do that. Oh, when we factor, we have to get one side 0, so we need to subtract 3 on both sides. Good. So you have 2x squared minus x minus 3 equals 0. Okay. Other valid options are completing the square, which I know no one likes. Also, the quadratic formula is also valid. Okay. If we want to factor, let's see if we can remember about the test. We need 2 numbers that add to what number? -1, and we need them to multiply to what number? -6. What 2 numbers do that? -3 and 2, good. Okay, so those 2 numbers add to -1, multiply to -6, okay? So that means I can rewrite the left-hand side as 2x squared, split up that middle term into negative 3x plus 2x minus 3 equals 0, just like we did before. Okay, what's my next strategy? Once I'm here. Grouping, I think I heard it right. So we're gonna take kind of half of it, group half of the left-hand side, group the right-hand side, and piece things together. Okay, so what does 2x squared and negative 3x have in common?
X.
X, good. And what am I left with on the inside?
2x minus 3.
2x minus 3, good. Okay, what can I take out of the right-hand side? 1, right? They both don't seem to share anything. So why don't we just take out a 1? And I guess we're left with 2x minus 3 there, right? Okay. What are my two factors? 2x minus 3 and x plus 1. Good. So just a little review from our test. Okay, once we're here, we can split each of these into two separate equations, right? So let me just take this here. We have 2x minus 3 equals 0 and x plus 1 equals 0, right? That's what we do when we have two factors. We can add 3 on both sides, divide by 2 to get x equals 3 over 2 on one side, right? The other one, if we subtract 1 on both sides, we get x equals negative 1. Okay. So all I did is I changed the inequality to an equation, and I used what we learned from our test to figure out what the answers are. Okay. So I know that I have two things on here. I have 3 over 2, which is about 1.5. So that's kind of like here. And I have negative 1, which is here. Do I fill them in or do I leave them open? I leave them open. And how do I know that?
Because of the original sign being less than.
Yeah, right. There's no equal to in the question. So there's no way I would have been able to solve this equation or solve this inequality and gotten a less than or equal to or greater than equal to sign, right? So I know these are going to be open. Okay, so same process. Okay, now we actually have to plug things in. We can't look at the equation and figure out what's going on. Can someone give me a number less than negative 1? Negative 2, good. And I know this is slightly boring, but we have our original equation. Okay, we can plug in negative 2 into that. Okay, 2 times 4 plus 2 less than 3, 8, 9, 10. Is 10 less than 3? No, right? So no arrow to the left. Okay, give me a number between negative 1 and 3 over 2. 0 is good. That's the number I like to hear. So we have 2 times 0 squared minus 0 is less than 3. Is 0 less than 3?
Yeah.
Yes, okay, so we can put our arrow between them. Okay, and I know all my examples look the same. I honestly did not mean for it to happen like that, but let's keep going. Okay, we have x equals, let's plug in 2, right? We can plug in 2, that's bigger than, 1.5, right? So we have 2 times 2 squared minus 2 less than 3. I'll save you the algebra. I get 10. 10's not less than 3, so there's no arrow to the right. So set builder notation. I'm going to use negative 1, 3 over 2. Do I get parentheses or brackets? Parentheses, good. Okay, this is what I would type into WebAssign. Any questions on what I've done? I think we have enough time to do example number 13. So let's work on that one. I'll give you a little moment to work on that. Our example here, the one thing I did a little bit different here is I didn't like have it all expanded out for you. So let me get Yaz to talk through actually solving the equation. Gosh, there you are in the back. I was like, where'd you go? All right, do you kind of want to give us a rundown of your steps?
So, step I have to distribute the x to x minus 4
Mhm.
and subtract 7 from the right side of the equality. It's equal to 3x squared minus 4x minus 7.
Mhm.
And since there was a coefficient of x squared, I had to multiply the coefficient by -7. And then I had to factor figure out what multiplies to -21 and adds to which was -7. So then I did some grouping and I got, well, first I had to expand it back out, so I did 3x squared plus 3x minus 7x minus 7. And then by grouping, I got 3x times x plus 1 and -7 times x plus 1, which led me to getting 3x minus 7 and x plus 1. And I set those equal to 0 to get my x values, which ended up being 7/3 and -1.
Nice job. Very good rundown there. Any questions about solving the equation? All right. Okay, then I got Stephen to kind of plot his answers here. Do you want to kind of talk us through how you plotted your answers?
Yeah, okay, so I took both of those, numbers, we got 7/3 and -1. And since the sign up there is, less than or equal to both, yeah. What do I call this again?
Dots, I guess. I don't know.
Dots. Circles are closed for them, and to make sure that, where to put the line on the left side, I took -2.
Mhm.
Place it in X, so it's -2, in parentheses, got -6 and -4. And
Mhm.
then it becomes -2 times -10, which becomes 20, which is not what's underneath the 7, so nothing on that side. And in the center, x equals 0. Is that for x? All that becomes 0. So 0 is less than or equal to 6. And on the right, x equals 3. Flip that for x, and inside the parentheses becomes 9 minus 4, which is 5, and then 3 times 5 is 15, which just like last one, not equal to 7. So
Mhm. Very good. Yeah, so I'm very sorry that all my examples had the arrow in the middle. I promise that there are some examples where the arrows go out to the side. I'll try to throw some more at you on like maybe the quiz review tomorrow. But as long as you check all the different sides, you know where the arrow's going. Any questions on how I got the WebAssign answer? All right. And I underestimated how much time this was going to take, so I guess I'll let you out a little bit early. I know you hate that.